Hi, I'm Josh, and to get us in the spirit of the Love Garden, I would like to take you all on a journey, a JavaScript journey, and we're going to do this together. But first, I'm going to take a selfie. 3, 2, 1, cheese! That was lackluster, but thank you anyway. All right. All the way on the left, we have a database floating off in the cloud somewhere. And all the way on the right, we have users. And this is pretty much every application, or most applications on the internet, when you get down to it. It's some fancy way for one or more users to write or read or do both in some database somewhere. Now, Prisma is fantastic. We all love Prisma, yay! It does all this stuff, or a lot of this stuff, that we need for interacting in our application code to database areas, the more back-end parts of the code. It gives us structure, it gives us safety, migration, schema gen, all this stuff. But what gives us that safety, that lovely happiness, what was referred to earlier as productivity and confidence by Soren, in the rest of the application code, the stuff that touches users, that's not quite so Prisma managed? It can feel, if you're writing just vanilla or plain JavaScript, that the Prisma stuff is this lovely walk in the park where you have structure, safety, protections, and the rest is the Wild West. So in case you haven't guessed it by now, I'm going to say that we need the types of docs and safety in the rest of our application code that Prisma already gives us. And does anyone want to guess what technology, what language or framework we're going to suggest as using that for that? TypeScript? TypeScript and generics, yes, thank you. Hello, I'm Josh. We're going to be talking today about adventures and type-safe Prisma clients using TypeScript. A little bit about me first. I'm an open source developer. I've been doing that for about 6 months. I focus on open source static analysis tooling in the JavaScript TypeScript ecosystem. Static analysis is stuff that looks at your code and yells at you without actually running the code. I also recently wrote a book, Learning TypeScript. You should all buy it. It's pretty good. Previously, I worked at Codecademy, before that Microsoft. Now I'm an independent consultant. Most of what I do is yelling at people about how they should use TypeScript and doing it for them. You can reach me on Twitter at Joshua K. Goldberg and on the internet, joshuakgoldberg.com. Paperwork out of the way, let's talk about the actual stuff. First, I introduced this journey that you have all embarked on with me, potentially against your will, sorry. Second, we're going to go over TypeScript. Why am I so excited? Why were several people shouting out TypeScript from the audience? We're going to talk about types generation, how Prisma, which, spoiler alert, is fantastic with TypeScript, does generate really interesting TypeScript code for us. We're going to go into generic types, the wonderful way that Prisma code gives us really strong type safety across all sorts of different models and queries, stuff like that. And then we're going to get into the fun part of the talk, the shenanigans, where I'm going to go over some of the weird stuff Prisma has to do. And we're going to end with a bit of philosophy, how to write types good. Is everyone excited about this? Are we ready? Let's do this. Yeah. Okay. Thanks. For the record, I did not have any of the beer at the beer garden, but I will later. All right, TypeScript. Why doesn't tech Twitter shut up about it? Why is this so popular? Let's take a look at this code. That's an excerpt from my book, Learning TypeScript, you should all buy it, called Paint Painting. Looking at this context of, or pardon me, this snippet of code without any context, we have vague ideas. We can really only guess at what it's supposed to do. What is painter? What is painting? What are these parameters? What is the result of .finish? There's no way of just looking at this code and knowing what it's supposed to do. You have no confidence in your code. And there is this community standard that sort of has a spec, kind of, called JSDoc, where you can write comments from your code. First of all, JSDoc comes from JavaDoc. And if there's anything that should convince you not to use a tool, it's that it comes from Java, right? But also, there's no real specification, and there's no enforcement of JSDocs in JavaScript. If someone were to refactor this code to take in a string instead of an object for painter or painting, or vice versa, there's nothing enforcing that we also update the docs correctly. So you don't have confidence in these docs. They are sometimes useful, sometimes harmful. So you don't know what these parameters are. You don't know if they're accurate. You don't know if they're correct, if they're even the right names, and you don't know what, still, the return type of painter is. What is this painting thing? So here's a snippet of TypeScript code, and you don't have to already be a TypeScript developer to understand this. You don't need to understand it, but you do need to appreciate and love it, as we all do, that this type painter says that, okay, the painter has 3 members or properties on it. It's got a finish method, It's got its own materials, and it's got a paint. So we know what painter looks like. And fun fact, TypeScript will yell at you. It'll build fail if you mess this up. We know what goes into even this paint method, and we know what comes back out from finish. We know this returns a Boolean at the end. So this is great. This is TypeScript. It gives us the confidence and the documentation that we need. And I'm going to go over a few really cool features in TypeScript because I think it's just such a cool type system and because we need it for the talk. To start, union types. Now, a lot of older languages like C# and Java don't have this concept, but it's a really important one. Sometimes you have a value that could be one of potentially two or more different types. Let's say that you have something that's either a number or a string. And we could represent this with a union type, number or pipe string, where let's say we have a variable and we can say assign a number or a string to the variable. But if we assign something else, Boolean, TypeScript knows that, okay, that's not on the allow list of allowed types. So that's the first TypeScript feature we're going into today, union types. The second is literal types. Union types are expanding the possible allowed set of types that a thing can be. Literal types restricts it. This bit type, which is shamelessly copy and pasted from a talk I gave that implemented binary arithmetic in a type system. This says it can be not just any old number. It has to be specifically 0 or 1. So if we have a mybit variable, we can assign 0 or 1. But anything else like 2, heavens forbid, not allowed. We can't do it. So we've expanded our allowed types, and we have restricted our allowed types with unions and literals, respectively. Cool. Are we ready to go to the next section? Yes. Thanks. OK, cool. Types generation. This is all actually useful and important stuff. It's not just cool because Prisma uses it. So this is a Prisma schema. Show of hands, who here has used Prisma before? Not everyone raised a hand. Odd. All right. And this can be represented by a very structurally similar TypeScript type, which Prisma actually does in its code gen. When you ask Prisma to generate your client for you, it takes in your models and it generates client code. And it doesn't just generate the runtime classes, the user delegate whatevers, it also generates types for them. So fun fact, these types are not exactly one-to-one with what's in the model. This doesn't have a posts array on it. And we'll get into later about, well, these optional fields, how do they get loaded by Prisma? But the nice thing about these types is that the client code can be annotated with them. So in the, for example, user delegate class that Prisma generates, we have methods like find many and find unique. And Prisma's code tells TypeScript what these methods return. So same as the painting method from before, we don't have to take any artistic license with it. We know exactly what they return, promises of user or user array. Now, we're going to start talking about the types that go into these methods. For example, find many might take in an args type like user find, which here I've defined as a much simpler type. I know there are many features in Prisma not covered. That takes an aware object, which has, let's say, optionally ID and email. So that gets a little tricky sometimes, because right now, let's say you do const user equals await Prisma blah, 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 user find, or find unique. We now know that the type for the user is going to be ID, email, password, name. So this is immediately a key benefit of TypeScript, reiterated, this time with Prisma, that we know what comes out of our functions. Because the Prisma code gen does all this for us. You don't have to write your own JSON serializer, deserializer for the database data or whatever. This just does it for you. But there's some magic that goes into the types. That if you include, say, posts true, if you add in and include to your find, there is also going to be an extra property on the returned type. What? There is no way to represent this in most languages. This is a beautiful thing where you can have the input to the function change the return type of the function itself. Or in slightly more technical terms, Prisma method return types change on their arguments. Fun fact, the argument is the thing going into the function. The parameter is what the function declares. So this is the key thing in the talk that I want to go over, because I only discovered this relatively recently, and I think it's really cool. Like, how does it do that? How does it change the return type of the function based on the arguments? Generics. Show of hand, who here has written a generic function before? Who here has like sworn at their computer angry words based on that generic function? Still a good number of hands? Yeah. Thank you for raising your hands. I want to give you an example, again, shamelessly copy and pasted from my book. You should all buy it. For this identity function, if you were to try to represent this function without generics, you wouldn't be able to. It takes in an input and then returns that same input as output. We need a way to say that the function's return type is the same as whatever was passed to it as an argument, that the return is based off of the argument. And this is how you do it in TypeScript, and also in many languages, like C#, Java. You declare a generic. There's this T type, and this T type can be different for every instance of this function, every call of the function. So if you were to call it with identity me, the T would be the me string literal, or for those who don't work in a language with literals, string, and it would return that same type. OK, cool. And you can have generic types too in TypeScript. You can say that there's this boxed type, which takes in a value generic. So if you were to say, declare a variable that's type boxed string, you could say box equals value head. But if you were to put some other type in the box, like the number 7, it would not be allowed. It would be a type error, because you already declared it as a string. Shout out to anyone who gets the movie reference. Conditional types are where it really starts to get cool, and I think this presentation picks up a little bit again. You can add logic to your type system. Pardon me. I'm so excited I can't speak. You can have a type that says, I take in a generic opponent, and if opponent extends rock, meaning is this type usable as the other type, then the resultant output type is something else. Let's say draw. And if otherwise the opponent extends paper, if it's paper, then the result is loss. Otherwise, the else, it's a win. So does anyone want to try to guess or infer the type of this against rock type? What would this result be? Rock matchup of rock. Shout it out. What was that? I couldn't hear you, but I think you said draw. Thanks. What's your name? Oh, I can't hear, so I shouldn't have asked that. I'm sorry. But round of applause for our friend over there who got it right. Thank you. And again, sorry, I can't hear anything. It's draw, because, well, that's what the logic says. It's rock, so it's draw. Against paper, it's going to be loss, and then against scissors, win. Cool. So we have logic in the type system. And that logic is really important, because we have already said that our goal is to be able to represent that the return type of a function is changed based off the arguments given. And fun fact, you can constrain your generic types. It's kind of like saying that a parameter is a particular type rather than any. Here we're saying that the opponent is only allowed to be rock, paper, or scissors. So fun fact, if you ever want to play rock, paper, scissors in the type system, first of all, don't. Second of all, this is how you could do it. Cool. So let's make this a little more useful. Suppose you have a function, trimmed length, which takes in text t, and t is allowed to be string or undefined. And you return the length of it after trimming it. That could be undefined if t is undefined, or it could be a number. So in this function, where we use an as-cast to kind of massage the type system, we are saying, and I'm going to go over it line by line, this number if defined type takes in a t, and it says, if that t is undefined, then my result is undefined. Otherwise, then result is number. Which means in my trimmed length function, if we know text is going to be a string, then the result is number. Otherwise, if we know it's undefined, the result is undefined. So putting that all together, if we do trimmed length of undefined, again asking you to shout out, what would be our return type for this version of the function? Undefined, thank you. Oh my God. I'm honest, it's always worrisome giving these. You never know if you're actually explaining things right. Because undefined is undefined, it extends it. So yes, undefined. How about if we take in the string Josh, what would the return result be? T would be a string. No, string doesn't undefined. What is it? Number, or 6. Sorry, someone was saying 6. Yes. You didn't have to count out, but thank you. Cool. So if we then give it something that could be either string or undefined, t is string or undefined, which means it could either be undefined or not, which means the result is number or undefined. Cool. That is the limit of the type system shenanigans that I'm going to go over in this talk. Cool. So now we've exhaustively covered these features in TypeScript, so we can talk now about how to represent the Prisma types, how Prisma takes in function arguments and then changes the return types based on them. So just to recap, this is what we want to represent, that when you add include posts true, it includes the posts field. So this is a slightly rewritten version of our user delegate class. We find unique, which takes in a generic args type that must be a user find. And the result is user finds it is two things. It is both a user and a new type, add posts if included, which takes in that args type. And add posts if included args says, given an args type parameter, if the args has an include, that extends post true, meaning if args.include.posts is true, if it has posts, then we add in an object that has posts in it. If yes, add posts. And if no, then we add an empty object, an object with nothing in it. So putting this all together, if we await prisma.user.findUnique, don't worry, I won't ask you on this one. I see the lack of enthusiasm. If we find unique where we don't have a post, then the args is where ID string does not have an include, does not have posts, so we just have user find with nothing else. And if we have await user.findUnique with posts, then we do have include posts true, so we add posts. So this is good. We are checking our return types. But that's not all, because Prisma actually has features like include, post, nested include categories true. So we're going to have to go through and write 4 to 5 levels of nesting in our. I'm kidding. We're not doing that. I want to instead switch over to the last part of the talk, type philosophy, because complex types are a simple symptom of complex logic. And I really want to emphasize this, that complex uses of TypeScript type system features are a symptom of your logic being complex. Show of hands, who really enjoys working with complex logic code? I asked this at the end. Put your hand down. If it's generics, yes. We have a joker in the crowd. I saved it for the end because fewest number of people will raise their hands. No one wants to work with complex code. And for generics, there's a golden rule from Dan Vanderkam's effective TypeScript, which is a quote also from the TypeScript team. If a type parameter only appears in one location, strongly reconsider whether you need it. For example, we have this shout function, which takes in a t, which is a string. It only appears in one location after declaration. There's no need for this function to have a generic on it. We could have just removed the generic and switched it to an input string. So I want to bring up, there's this Gartner hype cycle concept that gets floated around where something will get really exciting and everyone will want it, and then they realize all the things you can do wrong with it, and then eventually we figure out, okay, it's actually good, not amazing. TypeScript has its own hype cycle. It's gone through this cycle, and I think we've leveled out as a community, as a web development space. But each individual human, you and you and you, every one of us, when we use TypeScript, will go through our own little mini type cycle. We start off, we realize, oh my God, I understand generics now. This is great. I can add 4 generics to a function and infer everything. It's beautiful. And then you realize, much as you did during this talk, this is incomprehensible garbage, and I can't work with this. It's terrible. But then, when you stop overusing generics, you reach a plateau of productivity. And you realize there are times for these complex things, and there are times where you should stay the heck away. So, because people only understand and remember in forms of memes, here is Drake. You should not hate on TypeScript for having complex types. You should recognize that there are pros and cons. And these pros and cons reflect the way that most architects want to architect code. Your app types should stay simple. We don't want to work with complex types. The library types, Prisma can have 12 levels of generics nesting in their code because Prisma has to do complex stuff to make it so you, the developer, don't have to do complex things. I actually really appreciate the talks earlier about how you don't need to be the expert in everything. Let them do their magic. App code should stay simple, and library code should be complex only to assist you in your app code. Great. That's all from me. Just to recap, we talked about the journey we went on together, TypeScript, ? Types generation, generic types, how Prisma used those generic types, good stuff. If you want to learn more, typescriptlang.org actually has really good documentation. Props to their team. Prisma also has good docs on how they work with TypeScript, prisma.io/TypeScript. I wrote a book, please buy it, Also sponsor me on GitHub. I need your money to do open source things to make TypeScript world better for everyone. And most exciting of all, I'm doing a giveaway. Tweet at Learning TS Book and hashtag Prisma Day on Twitter about what you learned or wanted to learn for TypeScript to win one of 5 ebooks. So just to repeat, you could win a free ebook if you tweet at me. Yeah. Thanks. You've all won my affection and undying love. If you need a suggestion, I'm at Prisma Day and I want to learn TypeScript because something awesome, Learning TS Book. Okay, cool. Thanks, that's all from me. I hope you enjoy the rest of the conference and the beer. Cheers, everyone.